The name Cretaceous is derived from Creta, meaning chalk, in Latin. At first was proposed by J. Amalius de Halloy in 1822. He had been commissioned to make a geologic map of France, and part of his task was to decide upon the geologic units to be represented by it. One of his units, the terrain Cretaceous, included chalks and underlying sands. Chalks, a soft, fine-grained type of limestone composed predominantly of the armor-like plates of Coccolithoporus, tiny floating algae that flourished during the late Cretaceous. Most Cretaceous rocks are not chalks, but most chalks were deposited during the Cretaceous. Many of these rocks provide clear and easily accessed details of the period because they have not been deformed or eroded, and are relatively close to the surface as well. They can be seen in the white cliffs bordering the Strait of Dover between England and France. The Cretaceous is usually noted for being the last portion of the age of dinosaurs, but that does not mean that new kinds of dinosaurs didn't appear during the Cretaceous. It's during that time that the first ceratopsian and other dinosaurs appeared for the first time. Also during this time, we find the first fossils of many insect, plant, mammal, and bird groups, including flowering plants for the first time. The breakup of the world continent Pangaea, which began to disperse during the Jurassic period, continued. This led to increased regional differences in floras and faunas between the north and southern continents as the one supercontinent dispersed. The end of the Cretaceous also brought the end of many previously successful and diverse groups of organisms, such as non-avian dinosaurs and amenities. This laid open the stage for those groups which had previously taken secondary roles to come to the forefront. The Cretaceous was thus the time in which life, as it now exists on Earth, came together. Record is irregular in quality and quantity for the early part of the Cretaceous. However, it's obvious that dinosaurs continued their lengthy dominance of the land. The late Cretaceous record is much more complete, particularly in the case of North America and Asia. For instance, during the late Cretaceous, many dinosaur types lived in relationships and not unlike present-day terrestrial mammal communities. Although the larger dinosaurs, such as carnivorous Tyrannosaurus rex and herbivorous Iguanodon, are the best known, many smaller forms also lived in Cretaceous times. Triceratops was a large three-horned dinosaur. It was in North America during the Maastrichtian Age. And the Titanosaurs, a group of sauropods that included Argentosaurus and Dreadnoughtus, emerged different times during the second half of the period and were the largest land animals that had ever lived on Earth. At the beginning of the Cretaceous period, the tectonic plates had not separated completely. However, by the end of the period, Laurasia had separated into North America and Eurasia, and Gondwana had separated into South America, Africa, Antarctica, and Africa. Madagascar and the Indian subcontinent were still connected and would separate after the Cretaceous period. The Indian subcontinent colliding with Eurasia would form the Himalayas. The Cretaceous is defined as the period between about 145 and 65 million years ago, the last period of the Mesozoic era, following the Jurassic and ending with the extinction of dinosaurs, except birds. By the beginning of the Cretaceous, the supercontinent Pangaea was already rifting apart, so by the middle of it, it had split into several smaller continents. That created a large-scale geographic isolation, causing a divergence in evolution of all land-based life for two new landmasses. The rifting apart also generated extensive new coastlines, and a corresponding increase in available nearshore habitat. Additionally, seasons began to grow more pronounced as the global climate became cooler. Forests evolved to look similar to present-day forests. Oaks, hickories, and magnolias became common in North America by the end of the Cretaceous. At the end of that period, 65 million years ago, an asteroid hit Earth in the Yucatan Peninsula in Mexico, forming what's today called the Chicxulub impact crater. It had been estimated that half of the world's species went extinct at that time, but no accurate species count exists for all groups of organisms. Some have argued that many of the species to go extinct did so before the impact, perhaps because of environmental changes occurring at the same time. Whatever the cause, the extinction event marks the end of the Cretaceous period and, as a whole, the Mesozoic era. The climate remains similar to that of the Jurassic period, warm and humid. However, a few notable changes took place. The environment evolved to the point that flowering plants, or angiosperms, began to appear for the first time. This in turn contributed to an increase in insect populations. The land masses separated into continents that we would recognize today, although in much different positions than those we currently see. The climate began cooling for much of the period, resulting perhaps in the changes in flora and plant life. However, as it reached approximately 125 MA, the climate began to warm, due in part to volcanic activity and increased carbon dioxide levels in the air. The climate was generally warmer and more humid than today, probably because of very active volcanoes associated with high rates of seafloor spreading. The polar regions were free of continental ice sheets, their land instead covered by forests, believe it or not. Dinosaurs roamed Antarctica, even with its long winter. Sea level was higher during most of the Cretaceous than at any other time in Earth's history, actually. And it was a major factor influencing the paleogeography of the period. In general, world oceans were about 100 to 200 meters higher in the early Cretaceous and roughly 200 to 250 meters higher in the late Cretaceous than at the present. The high Cretaceous sea levels is thought to have been primarily the result of water in the ocean basins being displaced by the enlargement of mid-oceanic ranges and ridges. Throughout the Cretaceous period, life diversified and branched out. Dinosaurs remained the dominant species in the Cretaceous period, and they expanded, branching into previously less dominant species like horned dinosaurs. Insects diversified as well as birds. Mammals, although small, spread into many different species. For some of the geological record, more detailed subdivisions within zones can be developed for the basis of magnetic reversals. The Cretaceous period, however, has a dearth of magnetic reversals. Specifically, only 16 reversals are noted for the latest Jurassic to Aptian time, known for Aptian to the late Santonian time, and just 9 from the late Santonian to the Cenozoic boundary. Magnetic reversals occur far more frequently in Cenozoic rocks. While the cause of massive extinction brought on at the end of the Cretaceous period is debated, many theories exist, as you might think. There is evidence on plant decay, which would have contributed to the extinction, as all dinosaurs, whether directly or indirectly, depended on plant life. This could have been caused by large asteroid collisions or volcanic eruptions, or could even have been both. These events would have suspended sunlight, causing plant life to diminish. Other theories include the regression of the sea level, or a combination of many of these possibilities. Most of the species that survived were not as dependent on plant life. Insects survived on other animals and dead organisms, and mammals would often feed on those insects. This allowed the mammals to survive until the present day, when mammals would replace the dinosaurs as the most dominant species on Earth. The most famous of all mass extinctions marks the end of the Cretaceous period, about 65 million years ago. As everybody knows, this was a great extinction. It's where the dinosaurs died out, except for the birds, of course. The other lineages of marine reptiles, the ichthyosaurs, plesiosaurs, and mosasaurs, also were extinct by the end of the Cretaceous. As were the flying pterosaurs, but some, like the ichthyosaurs, were probably extinct a little before the end of the Cretaceous. Many species of foraminiferans were extinct at the end of the Cretaceous, as did the ammonites. But many groups of organisms, such as flowering plants, gastropods and pelecypods, which are snails and clams, amphibians, lizards, snakes, crocodiles, and mammals, quote-unquote, sailed through the Cretaceous Tertiary boundary with fewer extinctions at that time. The asteroid theory has met with skepticism among paleontologists, partly because the amount of iridium dispersed by the collision is more typical of that of a smaller object, such as a comet. Furthermore, terrestrial factors may have also played a role in the extinction. A huge outpouring of lava, known as the Deccan Traps, occurred in India during the latest Cretaceous. Some paleontologists believe that carbon dioxide that accompanied these flows created a global greenhouse effect that warmed the planet immensely. Others note that tectonic plate movements caused a major rearrangement of the land masses, particularly during the later part of the Cretaceous. Now, the climate changes resulting from such continental drift could have caused a gradual deterioration of habitats favorable to the dinosaurs and other animal groups that suffered extinction at the end. But, of course, it's possible that sudden catastrophic phenomena such as an asteroid or comet impact contributed to an environmental deterioration already brought about by terrestrial causes, which of course would have been a cooler end, which is why it's probably the most popular theory is an asteroid.